Hello. Today's lesson is on finding greatest common factor. In the past, you found greatest common factor by making factor lists and then comparing them, and then you find the greatest of those, and that's the greatest common factor. And that's a good way of finding the greatest common factor. However, sometimes factor lists can be very, very long and hard to find. Therefore, that method of making factor lists is not always the most convenient way of finding greatest common factor. Instead, a different method is using prime factorization. Remember, once you have the prime factorization of a number, you can find all the factors by combining together those prime factors. Every factor of that number has to also have at least some of those primes as its factors. So if we find the prime factors that are in common, then we find the common factors, and by combining them together, we get the greatest common factor. Okay, that was a bit wordy. Let's get started. All right. So, find the greatest common factor of 45 and 75. Using this new method, the first method is finding the prime factorization. I'm going to use factor trees this time. I will use factor ladders later on for a different example. So 45 is 5 times 9. 5 is prime, 9 is not, so I'll split it into 3 times 3. So the prime factorization for 45 is 3 times 3 times 5. Now I need the prime factorization of 75. 75 is 3 times 25. 3 is a prime number, but 25 is not. 25 is 5 times 5. So now those are all prime numbers, so its prime factorization is 3 times 5 times 5. Okay? Now I need to find the common prime factors. Well, they both have 3. 45 has a second 3, but 75 does not have a second 3, so they do not have the second 3 in common. Next, they also both have a 5. 75 has a second 5, but 45 does not have a second 5, therefore they only have a 3 and a 5 in common. So now we find the greatest common factor. We take the two common prime factors and multiply them together. 3 times 5 is 15, and 15 is the greatest common factor of 45 and 75. And this is how you show your work. All right, let's do another example. Find the greatest common factor of 20 and 60. All right, first I find the prime factorization, 20. I'll use factor ladders this time. Divide it by 2, I get 10. 10 is divisible by 2, so I'll divide that by 2, and I get 5. 5 is prime, so the prime factorization is 2 times 2 times 5. Prime factorization of 60. 60. 2 works, that makes 30. 2 still works, that makes 15. 3 now works, I get 5. 5 is prime, so this is 2 times 2 times 3 times 5. There's the two prime factorizations. Now we'll find what they have in common. They both have a 2, they both have a second 2, and they both have a 5. In fact, the only number they do not have in common is the 3. So now we'll multiply those together. 2 times 2 times 5. 2 times 2 is 4. 4 times 5 is 20. And 20 is the greatest common factor of 20 and 60. It is one of the two numbers because 20 is a factor of 60. Therefore, 20 is the greatest common factor because 20 is the greatest factor of 20, and it can't get any higher than that and still be common. Any questions on this so far? Make sure to ask your teacher. Here's a third example. 14 and 27. 14 divisible by 2 is 7. 7's prime, so 2 times 7. 27. Well, that's 9 times 3. 9 is 3 times 3, and 3 is 3, so that's 3 times 3 times 3. So find what they have in common. They have nothing in common. Does that mean they have no common factors? No, it doesn't. It means the greatest common factor is 1. Remember that every number, every natural number, has 1 as a factor. So if they have nothing else in common, then they still have 1 as the greatest common factor. No other number will divide into 14 that also divides into 27. Therefore, their greatest common factor is 1. There's a term for this. It is called mutually prime. It means that the greatest common factor is 1. No other numbers will divide into them. Neither of these numbers is prime. 14 is not prime, 27 is not prime. But together they are mutually prime because the only thing that divides into both of them is 1. So the greatest common factor is 1. So, to summarize, find the prime factorization of each number, find the things which they have in common, multiply them together, and you get the greatest common factor. If they have nothing in common, then the greatest common factor is 1, and the reason is that those numbers are mutually prime. That's it. It's as simple as that. Ask your teacher if you need any help.